Okay, so we're going to use the fact here, and by the way, arc sine of x is equal to inverse sine, and all the arcs are the same as the inverse. They are exactly the same, the different name for the exact same thing. So let's begin. So let me see. I'm trying to think of how the best way to proceed with this is. So what we want to do is, let's say we have y equals the inverse sine of the square root of 3 over 2. Well, what we want to do is we want to know okay, this is important. So when I have a sine function, I input an angle, and it gives me a point, right? The y value of a point, basically, or a value. But remember, for inverse functions, the domain and range switch. So if I want the inverse sine, I'm putting in a value, and I'm returning an angle. Clear? So you can say, okay, well, let's take the sine of both sides. Well, the sine of the inverse sine cancels. And basically what I'm asking for here then is, sine y equals the square root of 3 over 2. And I need to know what y is. What angle gives me the sine is equal to the square root of 3 over 2? Anybody? Anka? Pi over 3. Exactly. So here y equals pi over 3. Does everybody get that? How about B? So B, it says arc sine of -1/2. So what does that mean? Let's see, Arian. So what is the answer for that one? Sure. So I'm doing B. How do I do B? What's the answer? So I have B. I'm looking for y equals the arc sine of -1/2. It would be minus pi over 6. Very good. Minus pi over 6. Okay? Because when we look at a calculator, then remember, we're looking, the reference angle is pi over 6. Right? But that puts it in quadrant 1, and it makes it positive. And we know it has to be between minus pi over 2 and pi over 2. So it has to be minus pi over 6. Does that make sense to everybody? Yes. Because remember, I said, this is really important, that the inverse sine is only defined between all the things I said before we got to this was very important. So just so that you know, I have so little time with you guys. I know it feels like I'm talking forever, but I have so much material to cover in such a short amount of time that when I take a lot of time on something and I make sure that you understand it, it's because it's very important, okay? So the inverse sine is only defined between minus pi over 2 and pi over 2. So the range of the inverse sine of x is from minus pi over 2 to pi over 2. Is 7 pi over 6 in that range? No, so it's not the right answer. And it will be marked wrong, and it will not be given partial credit for that answer. Okay, because it's that you have to understand what's happening is that when we have this, remember I said the sine, the inverse sine, and the inverse tangent, and the inverse cosine. The inverse tangent and the inverse sine are defined between minus pi over 2 and pi over 2. And the cosine is defined between 0 and pi. Okay? Real important. So here, if I'm only defining it, so I know the cosine's got to be in one of these two quadrants. But can it be 11 pi over 6? Can I say it's minus pi over 6 or 11 pi over 6? Caesar, what do you think? No, exactly, because 11 pi over 6 is not between minus pi over 6, pi over 2, and positive pi over 2. Am I being clear? Okay, good. Now, the next question is C. So we have y equals inverse sine of 2. Delaney, what's the inverse sine of 2? Nope. Griffin, any ideas? Okay, Jackson? Anybody know? I don't need to go through everybody. Does anybody know? Nope. It's undefined. Because really we're saying, what is y when the sine of y is equal to 2? But remember, the sine of y can never be 2. The biggest it can be is 1, right? So it's undefined. Do you have a question, Jackson? Okay, good. So everybody gets that? You get that, Delaney? It's a trick question. Not really a trick, but you know, just this just tells you how to use your calculator. I'm not going to tell you how to use your calculator. If you need help with your calculator, I'm sure you all can figure that out. So here's the rule that we were talking about for the inverses. So number 1. If we say, so it's basically like saying if we have f composed, so if two functions are inverses, both of these things have to be true. Both, not one or the other, but both have to be true. Very important. And then we know it's an inverse. So Now, let's see, this is where things get kind of cool, tricky, fun, interesting, I think. So, let's see, who is next, really? Okay, so Damien, you showed up just in time. So, how do I do A? And you may not have been here for this part, so I'm not sure, because it looks like you just kind of showed up. Can you hear me? Oh, you can? Okay. Did you just show up? Okay, I don't know. Delane, you want to try? You want to take this one? This is more. Well, I won't put you on the spot again. Hey, Griffin, you want to try this one? Okay, sounds good.
Wait, do I need to have a calculator for this?
No, none of these are calculator questions.
Oh, okay. So
I'll tell you when the calculator questions.
Okay. These are similar to the ones that we just did?
Yes. So here, I'll do number one. I'll let you do number two.
All right, cool.
Okay, so number one. Does anybody know how to do it, by the way? It's okay if you don't.
Could you distribute this sign?
Well, it's not that you distribute it. It uses the fact that if f of x is equal to sine of x, and f inverse of x is equal to inverse sine of x, right?
Mm-hmm.
Then if I compose them, sorry, I don't know why it's looking like a 7. Those are all inverses. Then that's going to equal x, isn't it?
Yes.
So what is? Can you give me the answer now?
So 1/2.
1/2, exactly. The answer is 1/2. They just kind of cancel themselves out. Does that make sense?
Yeah, when you draw the formulas and stuff.
Yeah. And also, if you look at it like I showed you with the circles, right? If I go here through my f function, I start out, like, let's say I start out here with 1/2, and then I get to the sine of inverse. This one would be the inverse for this one. First, I'm going to do the inverse, right? Then I have to come back through the function. I have to get back to the 1/2.
Okay.
They do. They all cancel out. There's one thing that happens that's a little different, but it's not. It's not on this screen yet. So for B, it would be pi over 4. Okay. And how about for C?
5 pi over 6.
Hold on. I think I'm on the wrong screen. Yeah, I have something on my monitor that's blocking me. Okay, so 5 pi over 6. Now, is 5 pi over 6 between minus pi over 2 and pi over 2? No. So it can't be, it's not undefined. Here, let me show you what we have to do in that case. Okay, so I'm just going to erase. Well, I'll erase this. Okay. I'm just trying to get some space here to write on. Okay, so if I'm here, and I know my answer is 5 pi over 6, that means I'm in a quadrant that is positive, right? So the sign is positive here. Sign is positive. This is why reference angles are so important. So you want to know why they're important? Because of now. And they stay important. So I know my reference angle here is pi over 6. So the other place that sign is positive is in quadrant 1. So the answer to this is pi over 6. Because that will give me the right answer in the proper quadrant. For example, if it was 7 pi over 6, that would be here, right? So I still have my reference angle as pi over 6. But here my sign is negative, so I'd have to go over here to negative pi over 6. Am I making any sense yet? Sure, for the 7 pi over 6 or for the 5 pi over 6? Minus pi over 6? Okay, so if I was here, if I asked for, here, let me clear the page again. So if I asked for the inverse sine of the sine of 7 pi over 6. Well, what I want to do is I want to look at my circle. 7 pi over 6 is here in quadrant 3, right? With a reference angle of pi over 6. Does that make sense? Okay, well, but I remember I have to have it between minus pi over 2 and pi over 2. So because the sign is negative here, because it's in quadrant 3, the only other place the sign is negative is in quadrant 4, right? With the same reference angle. So it would be negative pi over 6.
Okay, so you're just making this like a second example. But for the sign,
yeah, this is just another one because I didn't want to just leave it at that one.
Okay, cool. That's why I got confused.
Oh yeah, I was just trying to make like I'm trying to have you see what's happening here. Does that clear it up?
Yeah.
Okay, good. All right. So we already talked about where the inverse cosine is defined. It's defined between 0 and pi because of our graph. We're not going to graph inverse functions, so no worries. Pretty much done with graphing. Here's the properties we talked about as far as properties of inverse functions. We already talked about all this. So now, let's go to, hold on. Okay, so what is the inverse cosine of 0? A. Let's see, who's next? Oh, Jackson took off. John. How do we do A? Well, so if I'm on a unit circle, here's 0. Is the cosine of 0, 0? So where's the cosine? The cosine of what is equal to 0? John. John, not Louis. Luis, sorry. I'm getting to you, Luis. Pi over 2. Exactly. Is pi over 2 between 0 and pi? Yeah, so that's the answer, pi over 2. You see, are you kind of getting it yet? We getting there? Okay, good. Okay, Kirkland, let's do B. So basically, what quadrant is the cosine negative? That's not a quadrant, and that's not the answer. What quadrant is the cosine negative? Good, quadrant 2 and 3, exactly. Now, where is do you remember where the inverse cosine is defined? I know this is all new, so it's okay. If you get it wrong, you get it wrong. It's no big deal. I'm just trying to, like, engage you guys. Between 0 and pi. So between 0 and pi is from here to here, right? So it can't be in quadrant 3, right? Yes, sorry, your microphone doesn't seem to be working. I know you're trying. Oh. Yeah, I got you. You can set it up after we get finished here if you want. So do you understand why it's not in quadrant 3? Okay, good. So we know it's in quadrant 2. So what is the reference angle for square root of 3 over 2? Cosine equals square root of 3 over 2. Do you remember? This part you guys really need to have down, the reference angles. Pi over 6, perfect. So pi over 6 is the reference angle. So what is the angle in quadrant 2? Not minus 5 pi over 6, just 5 pi over 6. Minus 5 pi over 6 would land you in quadrant 3. Who's got their hand up? Hold on. That's okay, no problem. Yeah, Griffin.
So if the answer is 5 pi over 6,
yes.
Why do we mess with the reference angle? Couldn't we just look straight at 5 pi over 6 and like notice that negative radical 3 over 2?
You know what all of it is, it's fine, but you know, it's not so easy to remember every single point, every single place on every single, I mean, I never asked you to memorize every point in every quadrant. All I asked you to do is memorize the first quadrant. So if you know the first quadrant, then you know that in the first quadrant, that's pi over 6, which is the reference angle. So you know, put that reference angle in quadrant 2, and it's 5 pi over 6.
Okay.
That's why reference angles are pretty powerful. Like, unless you have every single point everywhere memorized, which you may, some people may, but I'm trying to get away from having you memorize everything all the time. That's all.
I'm good. How are you?
I don't really have it all memorized, but I can kind of like visualize it. I'm just slow.
I think it's some of it is because you know where the reference angles are. I think more than you know, you use reference angles.
I believe it.
Yeah. Okay. Yeah. That's good that it's becoming just habit. That's awesome. Okay, let's see. C, Laura. So C is y equals inverse cosine of pi. So I'll just tell you, this is a trick question. It would not be -1. It's not really a trick question, but it always seems to be a little tricky. So it's not put on there to be a trick question, by the way. It's just to point out an important point. Well, it's in quadrant 2 or quadrant... Why is it in quadrant 2 or quadrant 3? It's not negative cosine. It's inverse cosine. Right, but the inverse cosine is between 0 and pi, right? So where would pi be? I guess what I'm trying to say is this is a trick question. It's a little tricky. Does anybody know the answer to this? I'll get you on the next one. I'll get you on the next one, Laura. No problem. This is a tricky one. Does anybody know the answer to this one? C? Nope. Oh, tricked you too. Nope. Nope. Yes. So yes, to get down, why is it undefined? No, that's not fair. Who else? Red one, why is it undefined? Yeah, because the cosine, basically what this is saying is cosine of some angle is equal to pi, but what is pi equal to? 3.14, right? Dot, dot, dot. But cosine, the biggest cosine could be is 1, isn't it? So you have to learn to think backwards. You really have to learn to think backwards. Does everybody get this? You got this, Griffin? You always tell me the truth, that's why I ask. Okay, good, good.
I think so.
Okay, cool. Let's
I guess we're just drawing circles and using reference angles and stuff.
Yeah,
we're not drawing equations like we do with the
in my mind because I've got that unit circle pretty much. I can like really visualize it pretty well. So it's not, you know, if you don't have it like that, which is fine. I've been doing this a lot longer than you. Then just draw a circle and just get your angles right. Just make sure, like if you write, if the answer is negative pi over 6, and you write 11 pi over 6, well, you have to write coterminal angle, don't you? But there is no coterminal angle in inverse functions because it has to be 1-to-1. So that's the really important point. Normally, those would be the same, but not with inverse, because with inverse, only a very small piece of that graph exists. Does that help?
I thought, well, that would be 10 pi over 6.
What would be 10 pi over 6?
Like if you combine those, the negative pi over 6 and the 11 pi over 6?
Well, no. But I mean, if you have a unit circle, and you have this angle, which is negative pi over 6, that's the same as 11 pi over 6.
Yeah, okay, yeah.
That's what I was saying. But they're not the same. They are the same sometimes. Like if I'm asking you what is the cosine of minus pi over 6 or what is the cosine of 11 pi over 6, they're equal. But inverse it doesn't exist. This does not exist if it's an inverse. We've already restricted the domain. Right?
Yep.
Just don't answer that is all I'm saying. It's like, that's the bad habit. Okay, well, let's do the same thing here. So, Laura, I'll give you this one. This one's not tricky. What's the answer to A? It's not a trick question. Promise. Jackson, I asked Laura. Why is it confusing? It doesn't matter what the value is. Yes. The only thing you have to be aware of is what quadrant that's in. So how do I know what quadrant 0.73 is in? Because it's not our normal look, right? Okay, I got it. So here's 0, here's pi, and here's pi over 2. Well, let's turn these into decimals. This is 3.14 ... That would make this I'll say approximately. That would make this approximately 1.57. Right? So it puts it in quadrant 1. Yes. So since it's in quadrant 1, it's fine. It doesn't have any, we don't have to do anything to it. If it was in quadrant 2, we would have to do something. Yes. Yeah, I know. That's the thing. It's like you're so used to seeing it as a symbol, but it's just a symbol for an actual real number. Okay? No problem. Okay, Lauren, what's B? Pi over 12. Exactly. That's all it is. Okay, Luis, I gave you the hard one. What is the answer to C? Okay, no problem. Well, let's just do it together. So so if we canceled everything, we would end up with 4 pi over 3, right? Okay. What quadrant is that in? I'm just going to do it out loud for everybody. It doesn't really help me just for you to give me the answer. So it would be in quadrant 3, right? So is cosine positive or negative in quadrant 3? Okay. Is the inverse defined as in quadrant 3? No. So where are we going to put it? No, well, first we have to put it into the other quadrant where cosine is negative, right? Which is where? Yeah, we're going to put it in quadrant 2. So in quadrant 2, we still have the same reference angle, which is pi over 3. That's right. So the reference angle is pi over 3, which makes the answer 2 pi over 3. So I guess we should do that. Okay? Is this making sense to everybody? All right. Good. Very good.